Good afternoon. Good afternoon, everyone. Good afternoon, Nanchika. Yes. Good afternoon, everyone. So let the students join. So I'm waiting for the 2 minutes. Good afternoon, Sarita ma'am. Good afternoon, Daljit ma'am. Exactly at 1:04 we'll start with this new theorem. As today we are going to start with the exercise 10 6.4. It is the beginning of exercise 6.4 and we'll start with this theorem for today's date. Yeah, good afternoon, everyone. Good afternoon. You can convey this message that students internals which they are going to get in September exams, they'll be able to know how am I giving. I have just made a report on each and every one. Okay, what I am able to see, who those who are attending classes, those who are sending me notebooks, those who are sending giving the test online or whatever other things. Okay, those who are active students, no, they'll get the best internals also. So one or two students have written here, sir, tests are checked. Yes, but the tests are checked from tonight after 9. I'll start sending you the messages, means your marks, how much you have got. Okay, or you can leave a message on WhatsApp, sir, tell me my marks. I'll tell that. Regarding notebook, I have not announced officially here in your class that you have to submit me the notebook. But yes, you will get the message now that you have to send me the notebook till chapter number 6. Okay, 6 we are doing till 6.3. Chapter number 1, 2, 3, 4, 5, and 6.3 till 6.3. Samareen, whatever you want to ask, no, regardless of this, you can ask me on WhatsApp. I'll tell you that. Okay. Okay, Yanshika. So it is now 1:05. Let us start. Theorem 6.6. What this theorem says. Now, proving of this theorem is not in our syllabus. Proving of this theorem is not in the syllabus. It is out of syllabus now. But we'll do questions based on this theorem. So that's why we are not doing proving right now. Just I am explaining you what is this theorem all about. Good afternoon, Ravindra sir. So ratio of the areas of two similar triangles. What is the first condition? The triangles should be similar. Means if the two triangles are similar, then just right here, what is the meaning of this theorem? If suppose triangle ABC, you can just note it down, note down these 4 lines in your notebook. Write down these 4 lines in your notebook. The ratio of the areas of two similar triangles is equals to the ratio of the, it is equals to the square of the ratio of their corresponding sides. Just write it down. Then I'm explaining you here what is this. If suppose this triangle ABC is similar to the triangle PQR, if two triangles are given similar, then area of triangle ABC upon area of triangle PQR means ratio of the areas of two similar triangles. So this is the ratio of the areas of two similar triangles should be equals to square of the ratio of the corresponding sides. So let us write the corresponding sides. AB upon PQ is equal to BC upon QR is equal to AC upon PR. Now these are the corresponding sides, and it is written here square of the ratios of the corresponding sides. So let us do square of these all. This is the theorem. If it is given in the question that two triangles are similar, and if the two triangles are similar, then we can use this theorem. Okay, so Garv is asking, sir, I have filled more than 100 pages. Yes, beta, all have filled the pages if they have done the chapters. You can send me one chapter PDF or 2 chapters together at a time. Okay, make 3-4 PDFs of 20 pages. Yes, then you can send chapter wise. You can send. It is easy for you also to check, and it is easy for me also to check. Okay, okay, yeah. So this is the theorem. This theorem we are going to use in this next exercise, exercise 6.4. No, Tushar, that is not possible even. So after this, yes, I have to check the notebook. Pratham is asking, sir, will you check notebook? I need to check. I guess I'll take 10 days to check your notebooks. So start sending me, and I want the notebooks by means tomorrow, day after tomorrow. Okay, now exercise 6.4. Triangle ABC is similar to triangle DEF, and their areas be 64 and 121. EF is given, and we have to find BC. So what is this triangle ABC DEF? Let us make these two triangles ABC and DEF. So one triangle ABC and the other triangle being here DEF. So ABC and DEF are the two triangles where the area of this triangle is also given 64 centimeter square, and area of this triangle is given 121 centimeter square, and here EF is given 15.4 centimeter, and we have to calculate here this BC, this side we have to calculate. So write it down. What is given? Area of triangle ABC is given 60. What to write? This. Wait a second. Just write directly. Since it is given in the question that ABC and DEF are similar, since, write the first solution. Since triangle ABC is similar to triangle DEF. Look here, I have told you just now, if the triangles are similar, then what we can use? We can use this equation. Okay, so if the triangles are similar, then therefore area of ABC upon area of DEF will be equal to the ratio of the square of the corresponding sides. The corresponding sides I am taking here BC and here EF. Why I am taking only these two? Because it is our choice. If you want to take all the three, you can take all the three. If you want to take two, you can take two. If you want to take only one, you can take one. So I am taking only one, which is which will help us to find out BC. So I am taking of this triangle BC and of this triangle EF. So these are the corresponding sides, BC upon EF whole square. Okay. After this, ABC we know that is given 64, and this area DEF area is given 121 is equal to BC. BC is not given, but EF is given 15.4, and this is whole square here. After this, 64 upon 121, we can solve like this. No, these are squares. No, so we can write here that this is the square of 8 and this is the square of 11. Squares cancel out, or we can say that unroot both sides. So we'll get 8 by 11 equals to BC upon 15.4. Cross multiply and take out the answer. BC into 11 equals to 15.4 into 8. And this is also here square. Square I have not written that. Or square will not come. Okay. So into 8 upon 11. And this is 1.4. And we can say that 11.2 centimeter. So BC is equals to 11.2 centimeter. So here we are finished with this. It's 15.4. No, 15.4 divided by 11 will be 1.4. So 1.4 multiplied by 8 is 11.2. Note it down. Starting with the easy question where only we have to find, we have not to prove anything. Wait a second. So this is the answer. So question number 1 is over here. I hope this is clear. Only we have used the theorem which I have taught you right now. If the two triangles are similar, then the ratio of the areas of the similar triangles will be equal to the square of their corresponding sides. Ratio of the square of their corresponding sides. Now moving on to the question number 2. Diagonals of a trapezium ABCD intersecting each other at O. So making a trapezium. A, B, C, D. Here it is given that AB is parallel to DC. Right, and given AB and DC are parallel to each other. And second, the diagonals are intersecting at O. So let us make the diagonal. Let's show the second diagonal. Make the figure in your notebook. And here we got the point O. Now AB is parallel to DC, and it is given that AB is twice of DC. This AB line is twice of DC. So this is also given that AB is twice of the side DC. And we know that in this exercise we are practicing the new theorem. So there should be a similarity of the triangles. Means, see this ratio, we have to find the ratio of the area of triangle AOB and COD. We have to find the ratio of the area of triangle AOB to the area of triangle COD. So what we have to find, area of AOB upon area of COD. This ratio is required. And we know that this ratio is only possible if these two triangles are similar. So let us prove these two triangles similar. In triangle AOB and triangle COD. In AOB and COD, we can say that let it be angle 1 and this has angle 2, alternate interior angles. Angle 1 and angle 2 are equal. Angle 2 of this and angle 1 of this are equal, alternate interior. And again, we can say that angle 3 and angle 4 are equal, alternate interior. We have vertical opposite also, so I'm just writing two angles, two pairs only I'm writing. Angle 4 is equal to angle 3, alternate interior angles. Therefore, we can say that triangle AOB is similar to triangle COD by a similarity criteria, and with the help of this we can say that since ratio of areas of two similar triangles, let us write that theorem, ratio of the areas of two similar triangles is equal to ratio of square of corresponding sides. I have written the theorem again so that you will be able to learn this. That ratio of the areas of two similar triangles is equals to ratio of the square of corresponding sides. So AOB and COD, no? So we can write here that area of triangle AOB, as we have proved them similar, so we can use this theorem. Area of triangle AOB upon area of triangle COD is equals to which sides we should take? We should take these two sides, AB of this triangle and CD of this triangle. Why? Because there is a relation given between AB and CD. Because AB is double of CD. See this? AB is twice of DC. I know. So that's why I'm taking here AB of this and DC of this whole square. Now AB is, since AB is twice of DC. So in place of AB, I am going to write twice of DC. And at down also we have DC. So DC cancels out. So here I have left with 4 by 1. So answer is 4:2. This is the answer. So AOB upon COD, area of AOB, you can write the same here. So this is the answer. 4:1 is the ratio. Okay, then is it clear or should I explain the things again? Simple similarity, and after that the theorem. Okay, similarity, then the theorem, and applying the theorem, and you will get the answer 4:1. Okay, after this, third part, third question. In figure 6.44, figure is already given. ABC and DBC are two triangles on the same base BC. Okay, ABC and this DBC are on the same base BC. See, ABC is also on BC, and this BCD is also on BC. Means BC is the common in both the triangles. Okay, if AD intersect BC at O, this AD is intersecting this BC at O, then prove this. How means it requires then construction. So construct here. Let me make the first of all trapezium. Make the trapezium A, B, C, D. Then BC is joined in the figure, so we have to join BC. And AD is also joined, so we need to join AD also. Make the figure. Here we have this O. Right, given. The given thing is means nothing much is given, but just write down ABC and DBC, ABC, and just write here triangle ABC and triangle DBC are on same base BC. Wait, yes, Daksh, what you were asking in the previous question, at place of AB, why I have written 2 DC. I have not written only DC, I have written twice of DC. Is there any problem here, Daksh? Because this is given in the question that AB is twice of DC. So in place of AB, we have written twice of DC, and DC then cancels out. Done? No problem? Okay. Okay then. So given ABC and DBC are on the same base BC, and what we need to prove, just write it down. Area of triangle ABC upon area of triangle DBC is equals to AO upon DO. How we can prove that ABC and DBC, AO and DO is not making any sense? Okay, then because of this, no, because of this reason we need construction in this. Draw AM perpendicular to BC and DN perpendicular to BC. Draw these two perpendiculars. So let us draw the perpendiculars. This and the other. Okay, and after this, just name them. Here we have AM, and here we have DN, and these are perpendiculars, so making 90 and 90. Okay, now let us start the proving part. Take these two triangles AOM and DOM. AOM and DOM. In triangle AOM and triangle DON. In AOM, we have angle AMO, and in DON, we have angle DNO, each 90 degree. Yes, these two angles are 90 and these are vertical opposite angles. So AOM and DON are equal. AOM is equal to angle DON. How? Vertically opposite angles. Sir, AO is perpendicular to BC. Garb has written. But AO is not perpendicular to BC. Where it is written that AO and BC are perpendiculars. AO, AD and BC are just diagonals of this trapezium. They can't be perpendicular. No, it is these are the diagonals of the trapezium. So that's why we have made perpendiculars here. AM and DN are the perpendiculars. Okay. So AOM and DON are also equal because vertical opposite angles. Therefore, we can say that triangle. Yes, Daksh, you are correct. AOM is similar to triangle DON by a similarity. So AOM and DON are similar, and because of this, we can write that AM upon DN is equals to AO upon DO by CBSE, and make it our first equation. Why I am doing this, you will get to know now. Why I have proved AM upon DN is equals to AO upon DO. Let me tell you now. Moving further to the next part of the question. Now see that what we have to calculate area of ABC upon area of DBC. So okay, I am calculating area of ABC upon area of DBC, and the formula says that area of triangle is equals to half into base into height. So wait a second. Half. My system is running slow today. This laptop. Okay, then half multiply by base. What is the base of this triangle ABC? BC. So I'm writing the base BC, half into base into height. What is the height of this triangle ABC? AM. So I'm writing here AM. Now area of triangle DBC. Just put the formula of area of triangle DBC. In DBC, the base is BC and height is DN. So half into BC into DN cancels out. So this is equals to AM upon DN. Make it second equation. From first and second, it is proved. Now from first and second, that ABC upon DBC is equal to AM upon DN, but AM upon DN is equal to AO upon DO. So we can say that ABC upon DBC is also equal to AO upon DO. So write here that area of ABC, triangle ABC, and area of triangle DBC is equal to AO upon DO. Hence it is proved. This is the final answer. Note it down. We'll do one more question, question number 4 now. If you have any confusion regarding this, you can ask. Okay then. Question number 4. Now, if areas of two similar triangles are equal, okay, right, given if areas of two similar triangles are equal, prove that they are congruent. Let us make first of all two similar triangles, two triangles ABC and PQR. It is given that these two triangles are similar. So area I'm saying triangle ABC is similar to triangle PQR, and area of this ABC is also equals to area of this PQR. So, and what we need to prove? We need to prove that these two triangles are congruent. Wait a second. So to prove triangle ABC is congruent to triangle PQR, how we can prove that these two triangles are congruent? If these two triangles are similar also and their area are equal also. So starting with the proving, no construction required, right? That since triangle ABC is similar to triangle PQR, then by the same theorem, that area ratio theorem, so I'm writing in short, area ratio theorem. There is no specific name given of this theorem. You should write the full statement the way I've written here. No, full statement I've written here. Ratio of the areas of two similar triangles. You should also write in the same way. Don't use any shortcut for this. Since ratio of the areas of two similar triangles is equal to ratio of square of their corresponding sides, therefore we can say that area of ABC area of triangle ABC upon area of triangle PQR is equals to AB upon PQ whole square is equal to BC upon QR whole square is equal to AC upon PR whole square. This is the theorem, no? That ratio of the areas of two similar triangles is equal to ratio of the square of their corresponding sides. And one more thing is given in this, that the areas are also equal. Areas of these two triangles are equal. It means ABC and PQR are equal in area. So in place of PQR, I can write ABC only because they are equal in area. And in front, I can write the same. AB upon PQ whole square is equal to BC upon QR whole square is equal to AC upon PR whole square. We are left with 3 minutes. So write it down and be quick in writing. So here we can write that since area of ABC is equals to area of triangle PQR. That's why we have written this. In place of PQR, we have written ABC. Now this and this cancels out, and here we are left with 1 upon 1. Okay, so we can say that AB upon PQ whole square is equal to 1. See, everything is equal to each other. So AB upon PQ whole square is equal to 1. Then PC upon QR whole square is equal to 1. Then AC upon PR whole square is equal to 1. So all of these, all these ratios I have written equals to 1 because they all are equal to 1 now. So we can remove this square and will be same 1 because under root of 1 is 1 only. And after that, here also BC upon QR, just remove the square. There will be no effect on the right side. In the same way, AC upon PR is equal to 1. Cross multiply, you will get here that AB is equal to PQ and BC is equal to QR and AC is equal to PR. Now we can say that in triangle ABC, it is written here. No, we have to prove that ABC and PQR are congruent. You can write that in triangle ABC and triangle PQR, AB is equal to PQ. It is written here. Then BC is equal to QR and AC is equal to PR. So by triple S proved above, we can write that triangle ABC is congruent to triangle PQR by triple S criteria, and hence proved. So note it down after this. No, we'll start the question tomorrow. We have 1 minute left, and in this time you can write this. Now listen, one more thing. Now onwards means I want to collect maximum notebook this Friday, Saturday, Sunday. So WhatsApp number is already with you. You can take the help of that and send me the PDF of notebook, uh, first and second chapter together like this, third and fourth together like this. You can send. Okay, then 5 and 6 together like this, and 6th chapter we are doing until 6.3. You can send. Okay, 3 PDFs you can send in this way. And if you are comfortable with one chapter also, you can send like this also. It is up to you. Separately also you can send. Fine. Yeah, if you are able to send all the means file together, you can send. You